Imagine the sheer frustration of losing the ability to walk after a stroke. It's something most of us don't even think about until it's threatened.
Yeah, absolutely.
But the buzz in research right now, it's all about how technology might be a real game changer in helping people get back on their feet, literally.
Exactly. And in this deep dive, we're really sifting through the scientific evidence on these, high-tech helpers, specifically overground robotic exoskeletons and other robotic systems.
Right, the ones designed to retrain walking.
Yeah, think of it as us doing the heavy lifting of reading all the dense research so you can understand what's truly promising.
Our mission today is really to cut through the noise and see what the most rigorous science tells us. We're talking meta-analyses, systematic reviews
Yep, pooling the data.
to understand how these robots can actually improve walking.
Yeah.
We want to know not just if they work, but, how and maybe for whom.
That's the key. So let's get into it. Let's kick things off with overground robotic exoskeletons, or REs. Now, these aren't just like futuristic concepts. You can actually find them in clinics.
Oh, really? Like which ones?
Think of devices like the Honda Stride Management Assist or the Exo, Bear H1, GMS, Hybrid Assistive Limb. There are quite a few now.
Okay.
And what's interesting is they're not just moving your legs for you. They're really designed to help you relearn how to walk. They assist and rehabilitate.
Right. It's about retraining the brain and body
Mm-hmm.
and the data. What's it starting to show us about how well they work?
Well, a big study, a meta-analysis, looked at all the research on using these overground REs specifically for stroke patients. And here's where it gets pretty fascinating. They found significant improvements in people's walking ability that's measured by how much help they needed to walk.
Okay, the FAC score.
Exactly, the Functional Ambulation Classification, or FAC score. And they also saw significant improvements in how fast people could walk right after the robotic training.
So, real practical improvements there. A better FAC score means more independence, needing less help.
Precisely. That's a really practical win. Interestingly, though, while people also seemed to walk a bit further, the improvement in their walking endurance wasn't quite as pronounced.
Okay. So speed and ability improve significantly. Endurance maybe less so.
Yeah, the effect size was smaller for endurance.
But even a smaller improvement in how far someone can walk, that can still make a big difference in their daily life, couldn't it? Like getting around the house.
Oh, absolutely. Even small gains matter. And the story gets even better, actually. The researchers followed up with people several months later,
Okay.
between 3 and 6 months after their exoskeleton training finished, and they found that the improvement in their FAC score, that walking ability measure, it was still there.
Really? So the benefits stuck around. That's great.
It suggests these aren't just short-term gains, which is really encouraging.
Definitely. Now, that study also looked at combining the robot training with regular physical therapy, right?
Yeah.
Did that make a difference?
It seems like it might have. They found that combining the overground RE training with conventional therapy actually led to a slightly bigger improvement in walking ability than just using the exoskeleton on its own.
Huh. So like a tag team approach might be best.
It kind of looks that way. It's like the robot gives them a platform to build on, maybe helps with the repetition and intensity.
And then the traditional therapy helps sort of fine-tune things.
Yeah, helps solidify those new skills, perhaps.
Interesting. Now, were there any hints about the ideal dose of this robotic training, like how long or how often you should use it for the best results?
There were some interesting signals, yeah. Not definitive, but signals. It looked like maybe longer training periods, say 6 weeks or more.
Okay.
Fewer sessions per week, maybe less than 4 times.
Okay.
And maybe even shorter sessions, like 30 minutes or less per session, might be linked to slightly better results.
Shorter sessions, too. That's a bit counterintuitive.
It is, but, and this is really important, these were just trends they noticed in subgroups. They weren't statistically significant differences.
Ah, okay. So hints, but not solid proof.
Exactly. The evidence wasn't strong enough to say for sure what the perfect recipe is. Still lots to learn about the how much and how often.
Right. And it's worth remembering, like the researchers themselves pointed out, the overall certainty of this evidence for overground REs was rated as very low.
That's a crucial caveat. So while it's promising, you have to interpret it cautiously. We definitely need more higher quality research.
Okay, so exciting initial findings, but we need more solid proof.
Right.
Got it. Let's shift gears slightly. What about powered overground wearable exoskeleton robots? The power ones.
Right.
There was a specific review just on those for stroke recovery, wasn't there?
Yes, a systematic review looking specifically at power in stroke rehab. And what's intriguing here is that this review found that training with these power exoskeletons, they called it PAD-G,
PAD-D, okay.
it wasn't actually any better than traditional gait training, CGT, for overall mobility right when the therapy ended.
Wait, really? You'd think the extra power would give it an immediate advantage, wouldn't you?
You absolutely would. It feels, yeah, counterintuitive. But there's more of the story.
Okay, good, because that sounds a bit disappointing otherwise. What else did they find?
Well, they looked at secondary outcomes, more
Huh?
specific things, and they found that PAD-G was superior to conventional training for improving walking speed and balance right at the end of the intervention.
Ah, okay, so speed and balance did get a boost from the power.
Seems like it. And even more interestingly, when they checked back later at the follow-up period,
Uh-huh.
the power exoskeleton group showed better mobility and endurance compared to the group who just had conventional training.
So the benefits for mobility and endurance maybe took longer to show up, but they were there later on.
Exactly. So while that immediate snapshot of overall mobility wasn't superior, these specific aspects, speed, balance, and then later mobility and endurance, did seem to benefit more from the powered training, and those benefits appear to last.
That's fascinating. It's like the powered aspect might target specific components of walking
Yeah,
that then contribute to better overall function down the line.
that could be one way to look at it, yeah.
Now, did this review tell us anything about whether using these power exoskeletons on their own was helpful?
Hmm.
Or even if just wearing one gave some kind of support, like an orthotic?
That's a really good question. And the answer is, well, no. None of the studies included in that particular review looked at using PAD-T in isolation. It was always compared against conventional training.
Okay.
And they also didn't investigate if simply wearing the powered exoskeleton without actively training provided any sort of passive orthotic benefit. Those are definitely gaps in the research.
Right. More questions to answer there. Okay, let's broaden the view again. What about the whole category of electromechanical and robot-assisted gait training? There's that big Cochrane review, right?
Yes, the Cochrane Review. It's a really comprehensive look, pulling together studies on various robotic and electromechanical devices compared to standard physiotherapy or usual care after stroke.
And what were the big headlines from that one?
Probably the most significant finding is that using these devices, this whole category actually increases the odds of someone being able to walk independently by the end of the training period.
Wow, that's huge. Regaining independent walking is such a major goal.
Absolutely. It's a massive milestone in recovery. So that's a really positive finding for these technologies overall.
Definitely. But what about how fast people could walk? Did this broader category show improvements there, too?
That's where it gets a bit more nuanced again. When they looked
Huh?
at everyone included in the review, there wasn't a statistically significant increase in walking speed overall.
Oh.
However, when they drilled down and looked specifically at the people who couldn't walk at all at the start of the study,
The non-ambulatory patients.
exactly. For that group, they did see a small but statistically significant improvement in their walking speed thanks to these devices.
So again, it seems like these technologies might be particularly helpful for those starting with more severe walking limitations, getting them moving.
That seems to be a pattern emerging, yes, helping to kickstart the recovery for those most impaired.
But what about the longer-term impact on their speed? Did those gains last for the initially non-ambulatory group?
Unfortunately, the Cochrane Review didn't find a significant increase in walking speed at follow-up for this group either.
So it helps get them started with speed, but maybe maintaining or building on that requires something else.
That seems plausible. It suggests that while these devices can help initiate improvements in speed for those who are non-ambulatory, sustaining and further improving, that speed likely requires ongoing, perhaps different strategies.
Makes sense. It's a tool, maybe a powerful one to get things moving, but not necessarily the whole solution on its own. Did the review mention anything about when to use these? Sooner versus later after the stroke?
Yes, they did touch on that. They were careful to call the evidence limited, but there was a suggestion that people who are in the acute or subacute phase, so within those first 3 months after their stroke, might actually see more benefit from these types of robot-assisted gait training.
Okay, so maybe intervening earlier with this tech is better.
It possibly aligns with the idea that the brain is generally more plastic, more adaptable earlier in the recovery process.
Right, the critical window idea.
Yeah.
Now, safety is always a concern. Did the Cochrane Review look at adverse events like mortality?
They did, and reassuringly, the review found no statistically significant difference in the number of deaths between the people who received the electromechanical and robot-assisted gait training and those who got the regular physiotherapy or usual care.
Okay, that's very important baseline information.
Good.
Now, you mentioned this review covered various devices. Did that variety cause any problems for the analysis?
Absolutely. That was a major point they highlighted. There was a lot of heterogeneity, a lot of variability across the studies they included.
Like what kind of variability?
Different types of robots, for one. You have end effector devices that just move the feet versus full exoskeletons that guide the whole leg.
Right.
Plus, big differences in how intense the training was, how long the programs lasted, and also the specific characteristics of the patients in each study.
So it makes it hard to compare directly or draw really broad conclusions.
Exactly. It's like trying to average the results from training with apples, oranges, and maybe some high-tech pears. It really emphasizes the need for more standardized research protocols moving forward.
Yeah, consistency would definitely help clarify things.
Okay.
Okay, let's zoom in on one specific device now. The Lokomat. I know that one's pretty well known.
It is.
There's been research specifically looking at how it affects balance after stroke, right? What did that find?
Yes, the Lokomat, which typically involves walking on a treadmill within a supportive exoskeleton structure. A review focused specifically on its impact on balance control, which is obviously crucial for walking safely and preventing falls.
And the verdict.
Well, the findings were a bit of a mixed bag, to be honest, which can be frustrating when you're looking for clear answers.
Oh, really? Mixed in what way?
Well, some studies included in the review did show that the Lokomat helped improve balance based on standard balance tests like the Berg Balance Scale or the SPPB.
Okay, so positive results in some cases.
Right. And sometimes it even seemed to work better than just regular treadmill training without the robot assist.
But
Then other studies found no real difference in balance outcomes when comparing Lokomat to traditional physiotherapy. And one study even suggested the Lokomat might have had a smaller effect on balance.
wow, that's quite the range. From better to no different to maybe even worse.
Exactly. All over the map, really.
So what did the researchers doing that review conclude from all this conflicting information?
They pointed to several limitations in the research landscape for Lokomat and balance. Things like a small number of really high-quality studies, many studies having pretty small groups of participants,
So sample sizes, yeah.
a general lack of long-term follow-up to see if any balance improvements actually lasted, and, of course, the inconsistent results themselves.
Right.
So their bottom line was that there's currently insufficient evidence to conclusively advocate in favor or against using the Lokomat specifically for improving balance after stroke.
Okay, so the jury's still very much out on Lokomat for balance specifically. It might help some, but the evidence isn't strong or consistent enough yet.
Precisely.
But did they mention any other potential uses or benefits for the Lokomat in therapy?
Yes, they did suggest that regardless of the direct proof for balance improvement, the Lokomat could still be a useful tool for therapists.
How so?
Because it allows for very precise control over leg movements and can facilitate a high number of repetitions in a controlled way. It might help therapists increase the overall therapy dosage, the intensity, and ensure more task-oriented exercises.
So even if the balance outcome itself is unclear, it could be a way to deliver more intensive, repetitive, focused gait training.
Exactly. It could help create a better environment for overall motor learning and recovery, even if the specific impact on balance measures isn't definitively proven across the board.
That makes sense. It's about how you use the tool.
Yeah.
Now, we focused heavily on legs and walking. Did any of these reviews briefly touch on robotic therapy for upper limb recovery, arms and hands?
Yes. Briefly, one systematic review looked at upper limb recovery specifically in people with chronic stroke, so quite a while after the initial event.
And what did they find for arms and hands?
In general, they found that robotic therapy alone wasn't significantly better than conventional therapy alone for improving arm and hand movement in that chronic stroke population.
Okay, so no clear overall advantage for robotics there, for most chronic patients at least.
Right, when comparing robot only to conventional only. But there was an interesting exception.
Oh.
The same review did find a significant difference favoring robotic training for upper limb movement, specifically in patients who are more severely impaired to begin with.
There's that theme again. Severity matters. So, for those with more profound arm weakness after chronic stroke, the robots might offer an edge.
It suggests that, yeah, perhaps the structured, repetitive, and potentially more intensive nature of robotic therapy might be particularly beneficial when you're dealing with more significant impairment.
That's a really important nuance. Now, stepping back and looking across all these different studies and reviews we've discussed, Were there any big-picture methodological things, like challenges or considerations that researchers and clinicians need to keep in mind?
Oh, definitely. Several key things came up repeatedly. One really important one is this idea of dose matching in the studies.
Dose matching, meaning,
Making sure that the group getting the robotic therapy and the group getting the conventional therapy receive the same amount of therapy time overall.
right, because if the robot group just gets way more hours of therapy.
Exactly. Then it's hard to know if it was the robot itself or just the extra practice time that made the difference. It introduces bias. And unfortunately, not all studies have been great at ensuring that dose matching.
That totally makes sense. You need a fair comparison to really isolate the effect of the technology. What about blinding? Keeping people from knowing which treatment they're getting.
Yeah, that's another huge challenge in rehabilitation research, especially with technology like this. In drug trials, you can often use a placebo pill, and neither the patient nor the assessor knows who got what.
Right, double blinding.
But in rehab, it's usually pretty obvious if you're strapped into a large exoskeleton or doing exercises with a therapist.
Yeah, kind of hard to hide a robot.
Exactly.
Yeah.
So blinding participants and often the therapists themselves is usually not feasible. And this lack of blinding can potentially influence the results.
How so? Performance bias.
Yeah, performance bias. If you know you're getting the cool, new, expensive robot treatment, you might be more motivated, push yourself harder.
Or the therapist might be more enthusiastic or have higher expectations.
Precisely. It's hard to control for those psychological factors when blinding isn't possible.
Okay, that's a key limitation to keep in mind when reading these studies. And one last thing I noticed, you mentioned lots of different ways they measured progress. FAC score, walking speed, endurance tests, balance scales.
Yes, the outcome measures.
Why is that variety important to consider?
That's a really key point for interpreting the field as a whole. The sheer variety of outcome measures used across different studies makes it much harder to directly compare their findings and synthesize the results.
So one study might show improvement on the timed up and go test, another on the 6-minute walk test, another on the Berg balance scale.
Exactly. And while they all aim to capture different important aspects of recovery, mobility, endurance, balance, functional independence, they measure them in different ways with different sensitivities.
Which makes pooling the data in things like meta-analyses more complicated.
It certainly does. Having more agreement in the research community on a core set of standardized outcome measures for future stroke rehabilitation trials would make it much easier to compare studies, pool data effectively, and draw stronger conclusions.
Right. More consistency needed there, too.
Oh.
Okay, so let's try to wrap up this deep dive. After wading through all this research, what are the main things you think we and our listeners should take away about robotic-assisted gait training after stroke?
Okay, in a nutshell, robotic-assisted gait training across various devices definitely shows significant promise, particularly for improving walking ability, that independence measured by FAC, and walking speed.
Especially for certain groups.
Yes, it seems particularly beneficial for those who are initially unable to walk, the non-ambulatory patients. And there's evidence suggesting it might work best when it's combined with conventional physiotherapy, not necessarily replacing it.
Okay. And timing might matter.
There are hints, though the evidence is limited, that starting this type of training earlier in the recovery process in that acute or subacute phase might yield greater benefits.
But it's not all straightforward positive results.
No, definitely not. The effectiveness can really vary depending on the specific type of robot used. Overground exoskeletons, treadmills like Lokomat, end effectors, and also which specific outcome you're looking at. We saw less consistent evidence for things like endurance and particularly balance.
Well, the overall quality of the evidence.
It's still developing. Many reviews highlighted issues like heterogeneity between studies, potential biases due to lack of blinding, and the need for better dose matching. So while promising, the evidence base still needs strengthening.
So it sounds like the main message is promising technology, particularly for ability and speed, maybe especially for more severe cases and when used with regular therapy. But we absolutely need more research.
That sums it up pretty well. We need more high-quality, well-designed studies. We need larger numbers of participants to get more reliable results. And we definitely need longer-term follow-ups to see if these improvements really last and translate into meaningful changes in daily life.
Right. Research needs to catch up to the technology, in a way.
In many ways, yes. To really figure out the optimal protocols, which device for which patient at what stage for how long, combined with what else, there are still many questions.
Okay. So as this robotic technology inevitably keeps advancing, getting more sophisticated, maybe more accessible, It really makes you think, doesn't it?
Mhm.
How can we integrate these incredible tools even more effectively into stroke rehabilitation down the line?
Mhm.
How do we truly personalize treatment, using this tech to help each individual achieve their absolute maximum recovery potential? It's such a fascinating area.
It really is. And beyond just the effectiveness, there are other big questions too, right? Like accessibility, cost, training for therapists. How do we make sure these potentially beneficial technologies reach the people who need them?
Absolutely. Lots to consider ethically and practically as well.
Indeed. And for those of you listening who want to dig even deeper into the studies we mentioned, we definitely encourage you to explore the cited research. We'll certainly keep an eye on this rapidly evolving field for future deep dives.